Hello everyone, welcome back to our YouTube channel, Becoming a ROS Developer. I'm Desire and today we've got Umer who has just completed the course ROS Basics in 5 days and he'll be giving us a presentation on that. So without any further ado, let me now hand over the platform to him so he can begin his presentation. Alright, whenever you're ready, Umer.
Yeah, hello everyone. I'll be giving a short demo of my project and at the end I will show a short presentation that I prepared about the project. So I have set up everything and checked all of the commands. As you can see, the topics are being published. As you can see, the scan, the odom, everything else. Now I'll run my project, which will force the robot to move slightly to the left of the right wall, and it will continue to do so. So let's run the project. As you can see, the project has started. Now the robot should move slowly with time. As you can see, the robot keeps a constant distance of 0.3 meter from the adjacent right wall, and it slowly moves it forward. And previously the speed was higher, so the processing time of the robot was slightly slower. So today I reduced the speed by 1/3 2.5 meter per second, and now it basically is slightly slower, but it allows the robot to process everything and adjust itself. As you can see, it is now facing a wall at the front and it is turning to the left, so that the wall is on the right side of the robot, and now it will align itself with the wall and it will continue to work as usual. Yeah.
Alright, so let's see it finish the lab and you can head on to the presentation.
Yeah, sure.
Alright, it must have stopped by now, isn't it?
Forward.
It must have stopped by now, right? That's about within the radius where it started.
And now, yeah, it is almost like lap is complete, I think.
Okay, alright. Okay, so it did
I'll
stop.
I'll stop the program, right?
Okay, it didn't. Okay, yeah, you can stop the program, it's fine. And then let's get into the presentation.
Yeah, sure. So basically, this is a simple project that follows wall, finds the wall, and keeps 0.3 meter to the left side of the right wall, and basically we implemented it in the codes, etc. was in Python, and we use ROS libraries, and basically firstly I tested it in simulation, and then tested it on real robot, and it faced a couple of challenges, but ultimately I was able to get it up and running. There are basically three scripts that I am using right now, and there are three nodes. So the first one is wall following node. The second one is a wall finder, which basically finds the wall, and the third script basically handles the odom values. About the inputs and outputs, the input of the complete architecture is the laser scan, which basically scans the surroundings of the robot and publishes that input, and then after processing everything and deciding where the robot should move, the robot publishes commands to wheel commands to cmd underscore velocity output. And then basically there are three basic functions. If it is too far, it basically turns to the right, and if it is too close to the wall, it basically turns slightly left, and if it foresees a obstacle ahead, then it turns left until there is no obstacle. So it basically can complete a lap and follow the wall. And finally, there are services and actions. The service that I am using is find wall, and the action that we basically use is record around, which basically logs the movement path. And these are the basic set of commands that I used to get everything up and running. The first set of commands builds everything. The second command that I used to list down the topics that are being currently used. Then we basically test the robot with a keyboard, and if it is working, then the next step is to basically launch our complete package and test it with the environment.
Yeah.
Yeah, so this is it.
All right. That's everything, right?
Yeah.
Okay, so I've got some questions here, so just give me one sec. All right, so one of the prerequisites of the project was that you're supposed to implement some form of stopping mechanism, right, by tracking odometry, correct?
Yeah.
Okay.
Yeah.
So as we have noticed in the real robot presentation, the robot did not stop when it got to the point it started, right? Can you explain to me what could have been happening there? Why did it fail?
Yeah, I think it failed because the system was not able to recognize that it has the starting position. It has reached this starting position. I think on the real robot, the odometry might be noisy, and the robot is not able to accurately re-enter that small threshold of I think it was 5 centimeter. And but in simulation it was able to reach its initial position and stop when it reaches that region.
Okay.
I think the real simulation in real system that the threshold condition was not triggered accurately, and that is why the robots kept on moving.
Okay, can you show me where that is implemented in the code editor?
Let me try to find it. Okay, so we are in the wall follower directory. Then we will wall following script, and Yeah, here it is.
All right.
In this command, basically, we check that if it is within the 5 centimeter limit, then it stops basically moving.
Okay. So can you go up? I want to see the name of the function. And all right. So execute. Okay. Right. Okay. Okay. So basically, because it failed, right? It you said it worked in simulation, right? But it didn't work in the real
Yeah,
robot, correct? Um,
yeah, exactly.
okay. So what could you have changed to have it work on the real robot?
What could have I changed
Yeah.
to basically keep it working? I think one of the way was to increase maybe the threshold, so it can increase its window of where it can see the threshold maybe to from 5 centimeter to 20 or 30 centimeter. We could also use a timeout function maybe so that after a complete cycle is completed, it can stop. And one advanced technique might be that we can set up some sort of landmark where it started and stop when that landmark is detected.
Okay. So let's say we would change. So if we increase this to about, you say it currently it's set to 0.05 of a meter, right, which is 5
Yeah,
centimeters. If
yeah,
we
yeah,
increase it to 10, right,
yeah.
so let's do that and then build it, and let's have it running in the background just to so that we can test later on, right,
Yeah, sure.
and then we can keep talking about this.
Yeah, sure.
So we mark the starting point at the moment. You can correct it with teleoff because would want to see, would want it to be in the place where we can see.
Okay.
I think the camera on the
Oh,
left
it's
is
on.
paused. Yeah, so
I think I should reduce the speed.
yeah. Oh, yeah. Or maybe try pressing K immediately after you trigger your linear.
Yeah.
Because then if you decrease it too much, it won't respond to angular velocities. That's the issue. Yeah, okay, I think that's a good place to start. So just let's have it face forward.
First, let's build everything so that the latest changes are saved.
Yeah.
Then let's source it. Topic list, we don't need to test it. We only need to run the script. So let's try it one more time.
All right. So as this runs, right? So I would want to also know, how do you guard against the robot stopping too early or stopping prematurely, right, when you implement this stop trigger, in your code. So I would want you to be explaining, like pointing line by line. It will be easier for everyone to comprehend.
Okay, so I need to explain the function line by line, right?
Yeah. You can maybe put your IDE on the left or on the right. Just leave one window for the cameras.
Oh, okay, sure. I'll do it. Open it up. Should I start?
Yes, go ahead. I thought you were looking for something, but yes, man, go ahead. Yes.
Okay. So basically, this is a function that basically monitors when the robot should basically observe the goal and where it should stop.
Mm-hmm.
So basically, it stores the starting point of the robot when it started moving in these two variables, first dot x and first dot y,
Mm-hmm.
and then it at every step it basically monitors the current x and y position of the robot,
Mm-hmm.
and it compares both of distance between xy coordinates of the starting point and current point, and if that distance is less than 10 centimeter, then
Mm-hmm.
it stops, and it also makes sure that the when the robot starts moving at the start of the program, it doesn't stop immediately. So it moves some distance, and after it has moved some distance, then it basically then when it reaches that threshold, it basically stops.
Mm-hmm. What's
So
that?
this is
Okay, what's the value of that move enough? That's what I want to know. So, how do you figure out? Okay, is it moved enough for you to, stop or start
uh,
recording?
I I don't remember exactly, but the basically the code that does this is that if total is greater than minimum move distance. So minimum was zero point 0.8 and zero point 0.8 meters. So it is, I think, 80 centimeters. And after 80 centimeters, if this condition is triggered, then in that case we can say that the robot has reached its initial position after doing a complete lap.
Uh-huh. Okay, I see. I think your robot failed there a little bit. Failed to avoid the wall, but okay.
Yeah, I think it is struck near.
So maybe just terminate execution because I don't think we would have enough time to actually try again. But that's all right.
Yeah.
That's all right. So okay, the other thing, let's talk about actions, right? So I would want to know, why do you think you were required to implement odometry via an action, right? Why didn't you not use something else like a topic or a service, right?
So basically, we used odometry function basically because we needed the values from the odometry, and they are basically we need them when we want to, and the other options like service or topics are not that much better than the current option that we.
Yeah. Okay. So what I'm saying is, you could have just published that information on some message, right, via topics to say, okay, I'm currently at this position, right? My question is, why use actions, right? Why use actions rather than just publishing the information on via topics?
Because we wanted, because when we first started publishing the information on, then it would be very frequent, and that might overburden the system. So basically, the action is when we use it to basically start and monitor progress and stop the long running project. We use it because use action because automatic action because we wanted to start recording, we wanted to send feedback, and we wanted to ensure that when the robot reaches initial position,
Mm-hmm.
the robot stops immediately. With topics, you cannot manage that whole sort of process,
Mm-hmm.
and topics are basically used only to stream data, and they cannot basically control when to do when begin or end.
Mm-hmm.
That is my understanding.
Yeah. It's correct. It is true, right? It is very much true. So yeah, well done on that bit. All right. Let me see. Do I still have any other questions here? All right. Not anymore. Thank you very much, Uma, for your presentation. You have terminated that program, right? Yeah. Okay. Good. So, all right. So let's wrap it up here, and then we'll finish our conversation on Zoom. All right.
Yeah. Okay. Okay. Perfect.
All right. Alright everyone, this was Umer's presentation, and I would like to encourage all those of you who want to try the courses we offer certification on to do so, and then you can also come and showcase your work here. Remember to run your code on the real robot first and make sure it's working. So until next time, keep pushing your ROS learning. Bye bye.